Okay. Okay. While this is all coming up, the next topic that we need to start today is also storage. So once I initiate the fault tolerance functionality, we will do a demo on this, and then we'll kick off and we'll understand what the storage options are and how they help. So this lab is kind of still booting up. So let's wait for a minute for the ESXi's to respond. And I think in the meantime, the VM is already residing over here on 6i5. So I will edit the machine. Okay, I would make it like basic details. Make it 0. Okay, let me power on this virtual machine now. Okay, let me move this VM. One other ESXi. Let me change the network for this one as well. Okay, so this VM is powered on. Let's wait for it to boot up. Now, yesterday we had already enabled fault tolerance on all the ESXi's. So what we did was we basically enabled fault tolerance on all of them. Okay. So now this VM is up. Let's verify the ping for this machine. It is responding on 202. So I would come over here, initiate a ping. Oops. Initiate a ping 10, 10, 90, 2, 2. Okay. And on this virtual machine, if I log in, so you see that I've got two processes which are running over here. And now on this machine, I need to enable FT, right? So for that, what I'll do is I'll make a right click on the VM. I'll go to the option of FT and then I'll click on the button turn on FT. Now we are going to create a secondary VM. So here it will ask that, where do you want to save the secondary VM? Now we can keep it on a different data store and we could keep it on the same data store as well. it is advisable that you should keep it on a different data store. So you see this machine is running on SAN01. So I'll choose a different storage over here, maybe SAN02. I'll hit next. I'll choose the ESXi on which I would like to run the machine. For example, the secondary one should run on ESXi 6, and then I'll hit finish. Okay. Now here it will basically start the process that we started last night. But yeah, this will take some time.
Okay.
So
So
mhm.
what's the difference between the HT and the DRS?
HA and DRS.
Is
Is
that?
that what? No, no. Your question is what is the difference between HA and DRS?
No, FT and DRS.
So FT is an option wherein you create a virtual machine and its replica is created on the other side, and then they are replicating. These machines are replicating. DRS is you take a virtual machine and you migrate it to another ESXi. That is what a DRS is. Right? This is vMotion over here. Here you are replicating it. This is a secondary VM that you create over here.
Okay,
You
I
get
got it.
okay. So now I've initiated the sync over here. Okay, let's wait for a few minutes and then this will get completed. In the meantime, let's start off storage. And while this is going on, we'll come back to it after 10-15 minutes and then it should be done. Okay, let's start storage. So in storage, um, when we talk about storage, we generally think about hard drive. That comes to the mind that this is the component where you're going to save everything. Now the question is, when you talk about a hard drive, what are the characteristics of a hard drive? How would you say that the hard drive is good or the hard drive is bad? There are basically three characteristics which are associated with the hard drive. The first one is the latency. Latency basically means the time it takes to complete one write operation, okay? Or the time it takes to complete one read operation, you know. So the time it takes to complete one operation is basically referred to as latency. The other parameter that you have is bandwidth, okay? What is bandwidth? Bandwidth is the speed at which the transaction happens. So for example, you have a folder, you have an ISO file, and you basically copy it from the C drive to the D drive on Windows. You will see a speed over there, copying at 20 Mbps, 40 Mbps, 50 Mbps. So that is basically the bandwidth, the speed at which the data copying is happening. And then in the end, you have IOPS. That is how many throughputs, how many transactions it can do. Okay. So if we talk about latency, the lower the number, the better for us. If we talk about bandwidth, the higher the number, the better for us. And if we talk about IOPS, the higher the number, the better for us. Okay. So these are the three characteristics of a hard drive: latency, bandwidth, and IOPS. And you know, uh, the bandwidth and IOPS, the higher they are, the better for us. Now, when we talk about hard drive, we basically have multiple
So
types of
sorry,
hard drive.
can you come again on the high ups?
IOPS is the transactions, the number of transactions it can do per second. How many read, how many write transactions it can do per second. That is basically referred to as IOPS, input output per second. That is what it refers to.
Okay.
Now, when we talk about hard drive, there are basically three types of, hard drives, at a broad level, you would say. The first type of a hard drive is basically referred to as SATA hard drive. What is a SATA hard drive? If I show you the picture for the SATA hard drive, so if we go to Google and if we type over here, SATA hard drive, we go to the images. This is what basically a SATA hard drive looks like. Okay. So a big box, okay, where you see a lot of moving objects. So if you open the case of this hard drive, this is something that you will see over here. Okay, so this silver disk that you see on the top is basically referred to as a platter, and this uh, pointed object that you see over here is basically referred to as header. It's like in the olden days, you had a gramophone and you put the needle on it and then it would play the song. Similarly, it would happen over here as well. So here what is happening is you have this header which is basically reading the data on the platter. So this platter rotates. Okay, it basically spins, and that is referred to as RPM, rotations per minute. So in a minute, how many times would this platter move? And if you see that I've got multiple platters over here, you've got multiple heads which are reading the data over there. Okay, so this is how it is. Now the SATA hard drive, if I talk about, like I was mentioning, that there are rotations. So you have a SATA hard drive which is a 5400 rotations per minute. Then you have the other one as 7200. Then you have 10K rotations per minute, and then you have 15K rotations per minute. Okay. Now, if you talk about the 5400 RPM drive, it can give you a maximum of, I would say, 50 IOPS. Okay. The 7200 IPM can give you a maximum of 80 IOPS. This can give you a maximum of 110 IOPS, and this can give you a maximum of 150 IOPS. Okay. So the SATA hard drives, that we had back, 12 years back or 13 years back, I mean, that is what you had. Okay. They were very slow. I mean, and that is what you had, and that is what you had to live with. Very slow. The IOPS were absolutely horrible, but that is what it is. Okay. Things changed, and time went by, and then we had SSDs that got introduced. Now, if you talk about an SSD, SSD is basically referred to as solid state drive. Okay. What do you mean by that? SSD basically means that if I show you a picture over here, you go to images. Okay. So this is what basically an SSD is. Okay. This is on the entire chip. You would not see, where is the case cover? Yeah, so this one. Right, you see this? This is basically what an SSD looks like. So you have one circuit board on which they put a lot of chips, and that is where you save your data. Okay, this is what it basically looks like. So when you talk about an SSD, there are no moving parts. Like if you talk about SATA, there are a lot of moving parts. Things are rotating, moving. The platter is moving. The head is basically rotating and trying to read the data. But in SSD, there is no moving part. Everything is on the chip. Okay. This is super, I would say, this is far better as compared to SATA hard drives. SSDs are pretty good. They have, brilliant characteristics as compared to the SATA hard drives. So if I talk about SSD hard drives, the SSD hard drives are basically of four types. You have SLC, you have MLC, TLC, and QLC. Okay. SLC means a single level cell. That means um, on the SSDs, the data is stored in form of a cell. Okay, it is stored in a cell. So in one cell, only one data is saved. In the other cell, you have the other data. This is what SLC is. MLC is that in one cell, two blocks of data are getting saved. This is what happens. Okay, and then you have A3 and you have got A4. TLC means that in one block, you know, three data blocks are getting saved, like A1, A2, A3, and then you would have A4, A5, A6. And QLC means that in one cell, you have A1, A2, A3, A4. Okay. 4 data sets are basically getting saved. So this is what the difference is between SLC, MLC, TLC, and QLC. Now, if you talk about SLC, this is super expensive. Okay. QLC, it's not that expensive because you're pushing a lot of data over here, and here you have the single data. Okay. So it depends on the kind of storage that you are buying, what kind of SSDs they are providing. Are they SLC, MLC, TLC, QLC? It basically depends on that. Okay. So here, these are the 4 types of SSDs that you have. Now, SSDs give you a very good IOPS. I mean, if you compare IOPS, bandwidth, and then if you talk about throughput, okay, these are pretty good, as compared to a SATA hard drive. A SATA hard drive would not be able to give you a lot of, IOPS and, throughput as compared to, SSDs. SSDs are pretty good. I mean, even, you buy the most basic or a most common SSD that will also give you IOPS, at least about 2000 IOPS. Okay. And if you remember when we were talking about the SATA hard drives, I told you that, 15K RPM SATA hard drive could also give you a maximum of 150 IOPS. So SSDs are basically taking the game on a higher end. I mean, that's a good option to have. Okay. Now, the problem is that few organizations are even not happy with the SSDs. They want something even faster. Okay. In comes NVMe. Okay. How does an NVMe looks like? Let me show that to you. So if you go over here now on Google and if you type NVMe, if you go to images, this is what an NVMe looks like. Okay. So it's no longer cables over here. So on the SATA hard drive, you have a cable, that you need to plug. On the SSD, again, you have the cable that you have to plug. In NVMe, there is no cable. It basically goes directly, like you see on the motherboard over here, and there is no cable that you have to attach over here. Okay. So it basically goes directly on your motherboard. You put that in, and that's about it. No cables, no power cable, nothing all that sort. It basically takes everything from the motherboard and gives everything to the motherboard. That's the reason it is super duper fast. Okay. This NVMe that you see over here can basically give you an IOPS of close to about 12 Gbps. Okay. So if you talk about SSDs, they can give you a throughput of 550 Mbps. This is what they can do. However, if you talk about NVMEs, they can give you a throughput of 12 Gbps. So this is 0.5 Gbps, and this is up to 12 Gbps. Okay. So these are, absolutely super fast. Think about, how many times, this is beyond this. So now these are the NVMEs that you're seeing over here. These are basically consumer class. These are not enterprise class. When you talk about enterprise class, something that the customer would basically be using in their storage. Now, when we talk about a storage is a big box wherein you would have a lot of hard drives. Now, depending on your storage, it can be a SATA, it can be an SSD, or it can be an NVMe. It all depends on the storage vendor that you're going for. It all depends on the model that you're buying. Depending on that, they will basically put their hard drives, that it can support. Multiple storage boxes can also have different types of storage. So that means that in one box, you can have SATA hard drives, you can have SSD, and you can also have NVMe. Okay. It all depends on the model that you're going for. Nowadays, SATA is basically an obsolete hard drive. Nobody uses it. It's either SSD or NVMe. Okay, SATA is almost negligible now, but it depends on the
Is it
storage
possible
model.
for a board to take three?
Sorry, say that again.
Is it possible for on one board for us to have the three?
Yeah, I mean, you can create different data stores, no? So what you can do is that, you have the SATA hard drive, you carve out a portion, and then you carve out a portion. This becomes
Okay.
your SATA data store, this becomes your SSD data store, and this becomes your NVMe data store. These are three different data stores, and then you can keep your different virtual machines on them as per the requirement. Okay? Now, when we talk about enterprise storage, there are many out there. Okay, there is not one or two storages that you can buy. You have a lot of different storages that you can buy, and one of them is basically a Dell EMC vmax. Okay, if you see this option over here, vmax is a storage that was owned by a company called EMC. Okay, and then I think EMC was later acquired by Dell, so it is now referred to as Dell, vmax all flash storage. If you talk about the storage, this is absolutely, lightning fast. I mean, if I open up this option over here, why is it not responding? Okay. So if you talk about vmax, so for example, this one, if I show you over here, okay, this is a vmax, box that you have. Now, if you look at it over here, this one box can give you 6.7 million IOPS. That is what the capability it has. You get a throughput of 150 Gbps. That is what you get. And you can scale it all the way to 4 petabytes. That is the kind of data you can host over here. Okay. These numbers are staggering. They are huge, but also you would have to pay a lot of money for this. I mean, this is an enterprise solution, of course. The better the option that you want, the more that you have to pay. But you have a lot of options available, via which you can configure this. All right, let's move along. Now in storage, you basically also have a concept which is called a RAID functionality. What is RAID? RAID is basically stands for redundant array of inexpensive disk. That basically means that earlier we used to have SATA hard drives. Okay. Now the problem with SATA hard drives is that there are too many moving parts. And what would happen is the SATA hard drive would crash quickly. Because of this problem, RAID was introduced. RAID is a mechanism wherein I can have two hard drives, wherein I can have the data basically on both the hard drives. That is what I can do over here. That is what the intention is. So for example, if I configure a RAID 1, so I would have a A1 data over here and A1 data over here. Now, the benefit is that if this hard drive fails, at least the other one is available, to provide you the data. Now, remember, this RAID concept is no longer available on the ESXi's now. I mean, there is no point of you to apply a RAID concept. Why? Because what would happen is you will buy an HP server, and on that HP server, you just need to have one single hard drive of 64 GB. Okay, and this can be an SSD. And you install ESXi on this directly. This is what you should do. Earlier, I mean, I would say 12 years back or 13 years back, when we had SATA hard drives, on which the ESXi was installed, at that point of time, you would configure a RAID. But now All those options are basically history. You don't have to configure them. So in the servers nowadays, you will only get an SSD. So simply have one SSD. You do not have to configure RAID. You do not have to configure anything fancy over here because SSD has a lot of endurance. SSD as a drive doesn't fail, every month or, it's not going to happen. You install ESXi once on that SSD, you will be buying an enterprise class SSD, and then you can forget about, for 2 or 3 years, nothing is going to happen over there. And the SSD will keep on running. Okay. So you just have one SSD on the HP server, install the ESXi, and that's about it. You do not have to configure RAID or any other concept. You don't have to do all that stuff. Okay, that's not needed now. Now, on the other hand, the storage guys, they would basically configure RAID. So what would happen is when you take a storage box, now there you are putting a lot of hard drives over here. Okay. Now, here you have a possibility that the hard drives can fail because when you have too many hard drives, there is a possibility, this can fail. And if the hard drive fails over here, you need something to back it up. Okay? You need something to back it up. So on the storage boxes, the storage guys will configure a RAID. Now, this is something that the storage team will do. This is beyond the scope of a VMware admin. So as a VMware admin, you do not have to worry about what kind of RAID that they have configured or what are they doing on the storage. That is something that the storage guy has to look at. We are only concerned about the logical volumes that they are creating. Okay. So what we are basically concerned is that, when they have a storage box, so on that storage box, what they will do is they will carve out a portion. They will carve out a LUN1, and this LUN1 is basically presented on the ESXi's. Okay. When the volume is presented on the ESXi, then how do we manage it? How do we configure it? All those things we will talk about it. Okay. But our responsibility is not over here. Our responsibility is over here. This is what we have to look into. Okay. Now, let's talk about that how connectivity would happen. Okay. So let me answer this question first. So let's take an example. You have an ESXi. Let's say that you've got two ESXi's. And let's say I have a big storage over here. Now I have to establish the connectivity from the ESXi to the storage. There are basically two options available to do this. Okay. The first option is referred to as iSCSI, and the other option is referred to as fiber channel. So what would happen is you would have a cable from the ESXi going to the switch, and then from the switch you would have a cable connecting to the storage, right? Now, this connectivity, this can be backed by iSCSI, and this can also be backed by fiber channel. So for example, if you have a desktop at home, and if I ask you to open google.com on that desktop, okay? So to open google.com on the desktop, you would either have a wired connection or you would have a wireless, a Wi-Fi connection. But you need one of the connections, right, to open google.com. Similarly, when the ESXi and the storage, they have to connect to one another, either you would go over iSCSI or you would go over fiber channel. Both the options are available. In the lab, I will be able to demo iSCSI for you. Fiber channel is something I will not be able to demo. Okay. If you take official training from VMware, wherein you pay thousands of dollars, you know, they would also not be able to show you the fiber channel connectivity. That is also not
No,
available
no,
for
no
them.
issue. I think I'm used to the fiber channel setup, so with that, I think I
Okay,
should be able to simulate it.
great, great. All right. So now let's understand what fiber channel is. Okay. So in fiber channel, I can talk about in theory. I can explain you at a theory level that what a fiber channel is, why this is needed, and how it is. So when we talk about fiber channel, the first thing that you would hear about fiber channel that it is very expensive. You have to pay a lot of money. Okay. The other thing that you would hear is that fiber channel is basically lossless. Okay. What do you mean by lossless? I'll talk about it. Okay. And most of the enterprises basically choose fiber channel. I mean, it all depends on, you know, what your budget is. If you're willing to pay, why not? Okay. If you cannot pay, if you cannot afford, then basically iSCSI is the option available for you. Now, the first question is, why is it expensive? Let me answer this question now. So what would happen is when you buy an HP server, on that HP server, if you need a fiber channel connectivity, then you have to install a card on the HP server, which is referred to as HBA, which is host bus adapter. Like on the HP server, you will install a physical network card. You would have a physical network card. You will have a video card, that you can put on the server. Similarly, for the fiber channel connectivity, you need to put a card on the HP server, and that is referred to as HBA, a host bus adapter. That is what it basically refers to. Now, how does it look like? Let me show you a photograph for it. So what you have to do is go to Google and type host bus adapter fiber channel. Hit the enter key. Go to the images over here. Okay. And this is what basically a fiber channel card looks like. Okay. Now, this fiber channel card has basically two ports. So this is a dual port fiber channel card. Okay. This is how the ports will basically look like. Okay. These are not the regular RJ45. Remember that this is not a regular RJ45 that you will see over here. These are different kind of ports that you see over here. Okay. Now, when you get these cards, they basically have a black cap on them. I mean, if you remember the picture over here, you see, they basically have a black cap on them. This black cap is basically to protect them against dust, so that no dust basically goes in these cards. So that's the reason you have the cap. And this is how basically the port will look like. Okay. So this is a dual port card. Now, if you see very carefully over here, it very clearly says that this is port 0 and this is port 1. Okay. So basically on one HBA card, you have got three numbers. First, there is a number called WWNN that basically stands for Worldwide Node Number. That means for this entire card, you have a number. You have one unique identifier for the card, which is basically referred to as WWNN. Okay. Then this port has its own ID, and that is referred to as WWPN. And this port also has its unique ID, which is called WWPN. Okay. So on one card, you have WWNN, which is the common global, the unique identifier for the card. And then every port has its own unique identifier as well, which is referred to as WWPN. Okay. So here I would have two WWPNs and one WWNN. Okay. Now this card that you see over here, there are many organizations who basically make up this card. Okay. There are many organizations who would make this card, but there are two which basically dominate the market. The symbol that you see over here, this basically belongs to Emulex. Okay. This is a company referred to as Emulex. And the second one is called QLogic. So Emulex and QLogic, they basically dominate the market. They have the highest, market share when it comes to the fiber channel HBA card. Now remember, this HBA card that you see, you will install it on every ESXi. So for example, if in your environment, if you have 100 ESXis or if you have 1000 ESXis and you want all those 1000 ESXis should have fiber channel connectivity, then on every HP server, on every ESXi, you need to install this card. Now, this can be a single port or a dual port, depending on your, preference. You can have that. So you could have a single port card as well, and you could have a dual port card as well. It all depends on what you want. However,
O-
uh,
Okay, how does this the product, the model,
mhm,
what's the effect on using different SFP on it? Because if you pick a particular model now, you slot it on the maybe Cisco or Dell device. Now,
mhm,
the SFP that you're going to put on it,
mhm.
can it be any SFP or the
No,
model
again,
has
it
to
has to be
be
compatible. So
okay?
when you buy the HBA card, they will basically tell you that, what is the SFP connector that you have to put over there. Okay. So SFP connector is basically this portion that you're referring to over here. This one that that has to be put on this card. So again, you will have to verify the connectivity. You will have to verify the compatibility. So if you are buying a Umilix card or a QLogic card, they will basically tell you that what the compatible options are and what you can go ahead with.
Yeah, because I know I had an issue in the past on it, and I think that was an error from me. I just removed SFP from one of the card, and I
Hmm.
plug it on another HB card, and
Hmm.
eventually it messed up the whole thing.
Yeah, yeah. We need to verify the compatibility. Okay, so this is the HBA card that will go on every ESXi. The next thing is, so we say for now that I've got two ESXis, okay? And on both the ESXis, I have an HBA, which is over here, and I've got an HBA, which is over here, okay? Now, what is the next thing? You need to get a switch. Now, I cannot use any generic switch. I have to use a fiber channel switch over here, okay? So again, I have to buy a different switch altogether. I cannot use the switch which I have in my environment. So what I will have to do is I will have to basically look for a fiber channel switch. And when I go to the images over here, okay, you would see that, this is how your fiber channel